Hi everybody, Miss Hannah here, where I'm going to go over the practice before the Unit 5 assessment. So you would have received this on Monday, and I'm hoping that you were able to go through this. Make sure that you understand it because, again, as you remember from Unit 4, our practice assessments look very similar to our real assessments. So I'm going to go ahead and get started. Sorry, I had to let my dog into the room where I'm working. All right, so we have an amount of fruit on an apple farm increases exponentially. So that should help us. And, we should visualize that it's not going to be a constant rate of change. On the first day, the fruit was counted. There were 6 apples. Each day after, for the next 4 days, the amount of apples quintupled or quintupled, meaning they multiplied by 5. So you can take a look up here. We have day 0, 6 apples, day 1, 30 apples. And again, like they said, that we multiplied by 5 each time. So you can see this right here, multiplied by 5, multiplied by 5. So that in itself should tell you this is the growth factor. And we should also know that what is my starting value? It's at day 0, we have 6. There's my initial right there. All right, so I can actually write an equation without even looking at these, which I always suggest that you do, because that way at least you have an idea of what it is that you're looking for. So I know that y, or some value, the total number of my fruit, is going to be, I start with 6, and it's being multiplied by my factor, 5 raised to the power of x or t. I'm going to put t for time, okay? Or d for days. So let's take a look here. What do I got? Well, I'm looking for what I wrote here based on what I know. A is equal to 6 times 5 to the power of d. There it is right there. So then it asks you, so anyway, now it asks us, sorry, I had to take care of something. All right, coming back here. So we've got the equation, right? So now what we're going to do is, hang on, let me fix this focus so it doesn't keep going in and out. Focus lock. All right, so now it says, explain how you know this equation represents the number of apples on the apple farm. So one of the things I really want to stress to you is you're going to be asked to explain how you know something on this exam. So what you need to make sure that you always explain the math. You always make sure that you explain the context, and you need to explain logically, give good detail and reasoning behind. So this is that MCL. So in this kind of a question, you're going to need to make sure that you cover that. So what I want to state is the initial amount is 6 apples. And that is when time is equal to 0. Okay? We also know that the amount of apples is multiplying by 5 each day. And you could be really specific, and you could say when at day 0 equals 6 apples, day 1 equals 30 apples, and you could say the growth factor is 5. Therefore, my equation would be the amount of apples equals the initial amount times the growth factor raised to the power of the number of days. Okay, so you want to be very, very specific. You want to call out math. I know the initial amount, what it is, when time is 0. I gave some context, meaning the amount of apples is multiplying by 5 each day, and you can make a reference here. Day 0 equals 6, day 1 equals 30. And then the logic is therefore the growth factor is 5, and you then make some more assumptions and conclusions. Okay, therefore my equation would be. Okay, so that hopefully you give lots of good detail. Okay, moving on to question 2. It says the equation below represents the number of bunnies living in a forest as a function of time. Which equation has the greatest growth factor? So again, you want to remember that when I'm looking at y is equal to ab to the x, remember that the growth factor is the b right here. So I'm looking for the greatest number in the b. So I want to look at 5/6, 12 over 7, 8/10, or 4. And just to kind of put some reference around that, we know that 5/6 is less than 1. Okay, we know that 12 over 7 is more than 1. In fact, it's 1 and 5/7. We know that 0.8 is 8/10, which is equal to 4/5, which we know is less than 1. And then this last one is 4. So 4 is a whole number. It's bigger than all the other numbers. So basically D is my equation with the largest or the greatest growth factor. Okay, moving on to the next page. We get into a contextual problem where now we're talking about medicine. The equation below shows how much medicine, M in milligrams, is left in a person's body H hours after they took the medicine. I think back to the problem we did in class about insulin. We did a couple of different problems in this unit on medicine. We also did a problem on caffeine. So you'll notice that as it stays in the body longer, it obviously decreases, which is why you see this 3/4, meaning it's breaking down. Please remember that if I was writing the problem it says that I am decaying at a rate of 1/4, or 1/4 is leaving the body. So when I write my equation, I want to know what is remaining. So this 3/4 is what's remaining in the body after X number or H hours. So again, just recalling that. So it's asking us right here, how much medicine will be in the person's body 5 hours after they took it. So I'm given the value of t, time. So I'm basically, and it also says I need to round my answers to 2 decimal places. So this is where I want to use a calculator. So I'm basically going to, and I'm going to actually write the equation here. M is equal to 1,000 times 3/4 raised to the power of, I know that my hours is 5. Okay, so again, you're going to use a calculator. Couple of different ways to use a calculator. I find for myself, just on a personal basis, that I like to convert 3/4 into 0.75 and raise that to the power of 5. So on my calculator here, I would again do 0.75. How did I get 0.75? Well, I can clear that out and I can say 3 divided by 4. 3 divided by 4 equals 0.75. And then I can raise that. That's 0.75 It's going to be raised to the power of 5. And then I get that amount, 0.237, okay? And then I'm going to multiply that by 1,000. And I get that amount, 237.3046875. But I need to remember it says round my answer to 2 decimal places. Therefore, I'm looking at, if I look at this, 2 decimal places means I'm looking at 1, 2. I'm going to look at the number right behind the 0, which is a 4. I also am going to notice that that 6 will push that to a 5, which will push that to a 1. So the final answer is going to be 237.31. And I need to make sure I get my units in there. What am I referencing? It's milligrams. Milligrams, mg. Okay. So how much medicine will be in the person's body 5 hours after they took it? 237 and 31 hundredths milligrams. Okay, so then what does the 1,000 tell you in this situation? So right there, it tells us how much medicine in milligrams was in the person's body to start. So 1,000. Again, when you explain this on the test, you want to be very specific. So 1,000 is how much medicine in milligrams, however you want to say it, just as long as you get all that information down. Or 1,000 is how many milligrams of medicine is in the person's body to start. Okay, so they took the medicine. So how much is in the person's body to start, or how much medicine they took? Okay, or the dose that they took. Okay, what does 3/4 tell you? Tells you, well, I'm going to say that we talked about that earlier up here. 3/4 is what's remaining. So I'm also going to say that 3/4 is the factor, because remember we're talking about a growth factor. You can also call this a decay factor. It's a factor, I'm going to say decay, of medicine left in the body after each hour. Okay, so remember up here I referenced that we were talking about that it was decaying at 1/4. So what's left? So 3/4 is a factor. The decay, the growth factor, it's not growing here, it's decaying, of medicine left in the body after each hour. So every hour, there's always 3/4 of the previous hour. So you can even reference that, 3/4 of the previous hour. Okay, so again, lots of good detail. You want to make sure that you do that when you give an explanation. Then it says to go ahead and graph the equation for the amount of medicine. And on the test, we are looking at having you graph. We're trying to figure out how that's going to look. But I think it's really important for you to know how to graph. And I'm going to make this really simplistic, especially if you have to do it by hand, is I would make a T-table. It keeps my numbers organized. And obviously we want to start, it even tells us between 0 and 5 hours. So that's going to be my time right here in hours. So I'm going to use 0, 1, 2, 3, 4, and 5. And then what I'm going to do is I'm going to figure out how much medicine. So that's M. So if I plug in 0, I know that that's what I started with, which is 1,000. And if I go in here and I plug in 1, that would mean 3/4 raised to the power of 1. And I'm going to, again, reference back. I'm going to say 0.75. So 0.75 times 1,000. Again, putting that into your calculator is 750. Then I'm going to go raised to the power of 2. So again, I'm going to go 0.75 raised to the power of 2. And I'm going to multiply that by 1,000, which gives me 562.50. I'll just do number 3. So what I do here, here's my calculator. Turn it on. I'm going to go 0.75. Right there, 0.75. I'm going to raise it to the power of 3. Hit the total button. I get an amount. Then I'm going to multiply that by 1,000. And I get 421.875. So 421. In fact, I'll just say 422. I'll round it up. Take a look. Rounding it up to the next whole number, 422. And I'm going to do the same thing for the power of 4. When I put everything in, I get 316. And the last one, raised to the power of 5. And I really encourage you to please do this. If you have a phone, your phone will calculate. You could do it on the computer anyway, but really, if I'm doing these here, you really should do them yourself to make sure that you get the same answers, because you're going to need to do this on an assessment. So 237. It ends up being 237.3, but I rounded it just to 237. Okay, now we need to graph it. So again, you're going to notice the graph. We've got time on the bottom and medicine in milligrams on the left. So I'm going to simply go 0. Here's my 0. Where's my 1,000? I'm going to go all the way up to 1,000, which is way up here. Okay, and I'm going to continue noticing, okay, how am I counting? Well, if that's 800, it seems there's 4 of them, so each one of these is 25. Okay, so I just need to remember that. So this is 1. So 1 and 750. So here's 1. I'm going to go all the way up to 750, which puts me at about right there. Then this one I have to eyeball. It's going to say 562. So 563. So I'm going to go 2. I'm going to go up to 5. Let's see. There's 500, 525, 550. So I need to go just a little bit above that. So just a tad above that, about right there. And then I'm going to do the next one. 3 and 421 or 422. So 3 and 400, 425 is right there. So just the shad under the 425. And then 4 and 316. So again, 4, go up to 300. This would be 325. So I'm going to go halfway between. And then you're probably going to go, wait a minute, that looks like a straight line. No, it's not. It's not a straight line. In fact, the only reason why it looks fairly straight is because the numbers are fairly spread out. So, and the last one is 237. So I'm going to go 5 and 200, 225, about right there. Okay, so now I'm going to go ahead and connect. Again, if I'm graphing, please always connect. You could see that it's curved. It's not, I didn't do a perfect job there, but I did relatively a good job. So again, we know that it is not a straight line. How do I know that? Because 1, I've got a growth factor of 3/4. That means that's fairly close to 1, which means my curve is going to be relatively, quote, flat. Remember, if I had a growth factor of 4, it's going to go up higher. This, again, remember, is less than 1, and this is actually closer to 1 than closer to 0. So that means it's going to be relatively a flat curve down, okay? So, again, that was lesson, I believe, lesson 12 and 13. All right, so moving on to the last page. This is a little bit, if you look at this problem is very, very similar to Genie in a Bottle, the one that you found on a beach at the beginning. And of our unit where we talk about which one do you want to take. But before we do that, we need to do some math around what we've learned in this unit so far. So let's see here. We've got congratulations, you just won a lottery, and you get to choose how you're going to get your winnings. So we have two options. Option A is you're going to receive $1,000 each month for the rest of your life. Or B, you're going to receive $100, which you can then invest in a fund that makes 2.5% interest every month. Okay, so I want you to remember $1,000 each month. Okay, what else do I know? $100 gets invested in a fund that earns us 2.5% interest every month. Okay, so you got to pay close attention to this month. Again, how are you going to write that as a decimal? I'm going to write that as 0.025. Okay, so why is that such a big deal? Because you're going to need that information. We don't write our equations with percent signs. Okay, so now it says we're supposed to write an equation that represents option A. Define my variables. Okay, so let's go up to option A. You receive $1,000 each month for the rest of your life. So what do we want to say? Total for T? How about total for option A? So how about if I go TA is the total for A. That's how I'm going to do it. All right, what's my other variable? My other variable has got to be something to do with months. All right, so how about if I write M is equal to months? That's my time. Okay, what else do I know? Well, I know that I'm going to receive $1,000 each month. So I'm not going to be adding. Remember, adding is too inefficient. So every month I get 1,000. In 3 months, I would go 1,000 plus 1,000 plus 1,000. Way too complicated. Remember here, to simplify it, repeated addition means I can multiply. So T of A, TA, is going to be 1,000 times the number of months. Okay, so that means if I do 6 months, I go 6 times 1,000. If I do 1 month, I get 1 times 1,000. If I do 24 months, 24 times 1,000. Okay, so I've defined my variables and I've got my equation. Okay, now, next one. Write an equation that represents option B. Define my variables. Okay, what's going on with option B? You receive $100 and you invest in a fund that makes 2.5% every month. All right, so again, I'm going to use my same thing, T of, oops, not A. This time I'm going to go T of B. And that means my total for option B. And I'm going to use M again. Why not? Is going to be months. Okay, so I define my variables. And what else do I have to do? Now I got to write my equation. Well, this is where you have to remember, what did I start with? So T of B is going to be 100. Okay, and remember, 2.5% interest every month. Remember what happens with interest. This is always going to build on the prior month. So again, drawing my little diagram. Love that little diagram. Here's my $100. So what's going to happen for the first month? I'm going to add on 0.025. Okay, so then remember this is 1 and this is 0.025. If I add those two together, I get 1.025. Remember, every month after that, I'm going to take this and I'm going to add on another 2.5%. And then my new amount is going to always be on the succession of months. So I don't start back over. I always keep adding. Okay, so we got to remember that I've got 1 plus right? So this means 100 times 1.025. And what is it going to be raised to? It's going to be raised to the power of m. And that m is going to be my number of months. So again, if I want 10 months, I'm going to go to the power of 10, multiply, and then multiply by 100. Okay, so now it's asking, next question. Assume that we are going to live for approximately 50 years. What option is going to earn us the most money? Well, I have to calculate for both. So let's do option A. So option A says, remember my equation right up here. So what's my m? My m's going to be, this says 50 years. So, and I've got m is equal to months. So I got to calculate how many months is that. So I got to come down here and I got to go 50 years is equal to how many months? So I'm going to take 50 times 12 equals 600 months. Right? 50 times 12. Double check my math. 50 times 12. 600. Phew. All right, 600 months. So now I got to go in and I got to substitute. So the total amount for option A is going to be 1,000 times 600. So how much money is that going to be? In 50 years, $600,000. Okay, not so bad. Now let's look at option B. I take 600,000. Option B, 50 years equals, here's my equation, 100 times 1.025. Okay, remember, this is months. So I need to figure out in 50 years, how many months is that? We just calculated 600 months. So it's going to be 1.025 raised to the power of 600. Let's go ahead and do the math. Okay, here's my calculator. 1.025 raised to the power of 600 equals, wow, look at that. Now I got to multiply that by 100. Oh boy. This is equal to 271,843,676. 50 cents, right? Here's that number right there. Okay, now, this is, but I need to figure out, I need to know how much money that is. $271,843,676.50. Okay, which one's going to give you the most money? Bingo, right there. Okay, now, here's option A. Okay, now it says, which option do you think is the better option? Well, you've got some decisions to make, right, ladies and gentlemen? You want option A? Or do you want option B? You need to decide. You need to justify it. You need to explain. You need to use the math. You need to write it in context. You need to sound logical. Okay? So, you decide. You need to explain why you chose it. Some of you may say, you know what? I'm going to take this sure thing at 600,000. because it's asking you which option do you think is the better option. So it has nothing to do with 50 years here. Sorry, I misspoke. This has to do with just in general. Look up here. You've won the lottery. You get to choose how you're going to get your earnings. Do you want to take $1,000 every month for the rest of your life? Or do you want to take $100, which you can then invest and you earn interest every month? You need to make that decision. This is like real thing. You could win a lottery and you could very well be asked, do you want the lump sum amount? Do you want to take it over a certain amount of time? Or do you want to invest that? And could it grow? You're gonna tell me. Option A, option B. When you justify it, tell me why. Gosh, you know what? For the rest of my life, I'm gonna get $1,000 every month. I could really use that $1,000. Option B, wow. You know what? I'm not gonna start out with very much, but over time it's gonna grow. Look in 50 years' time. Right? It's up to you. Make sure. MCL. All right, guys. When you next hear from me, it'll be about the assessment. So hopefully you found this helpful. One thing I am going to stress to you is get the work done. That's the best thing I can do. Reach out to me if you have any questions, okay? I'm available for you.